Hello everyone. Oh, there was a bit of a jingle there. I'm just going to talk a little bit, welcome you back, those of you who've come in on time. I'm hoping other people will join us because we have Mel up next, and I want to make sure we have a full house for Melchiorre Conti. We could have a chat about other things whilst people just walk into the room if you want, Mel. Why not? We can just have a chat about your wonderful son. How is he?
He's fine, thank you. Oh. See?
That was somebody else.
Build it and they will come.
So we just want people to come into the room because you are going to talk about...
I'm going to talk about something that is very, very interesting and long-ranging. We're going to highlight and discuss more the pillars that the director of HRE, Daniel, introduced. I will give a much more in-depth still high level, of course, but much more in-depth view of what they represent, why they're there, and what's the synergy among all of them. And as usual, it would be in line with what also the DG said about the development of procurement activities in a more commercial and sustainable way, and how for the regolith-oriented utilization, we will plan to do that. And it's a long-ranging plan, which actually started in 2019, and we will give a view of what we intend to do moving forward up to E3P6. Yes, I don't remember exactly which are the dates, but it will come up on the chart so that I don't have to remember and make a fool of myself.
No, so. Well, I'm sorry. I can see there's more people in the room now, and I just wanted to really encourage people to come back. I know it's always hard being the first one up after lunch, but you did so well to be here on time. And I would also really like to welcome back people who are watching online. And of course, as always, you can log into the program, log in to view the session. Of course, we're in the 1:30 session, and there you can ask your questions. I know also we have lost half the room, hopefully, to Dovile, who is going to talk about law and regulatory aspects of space. She is with the Luxembourg Space Agency, and she's in -2. So thank you for being back in the room. And with that, of course, I would love to welcome Melchiorre Conti.
All right. Thank you. I'm Melchiorre Conti. I'm a space resource engineer. I work for the Directorate of Human and Robotic Exploration at ESTEC, based in the Netherlands. And I will give an overview of the new project plan, which has a very long name, but the bottom line is, how are we going to make the commercial aspects and the emergence of commercial operator possible in due course, through the activities that we will carry out in the coming cycles and years. So, because this is about collaboration, it's important to remember that what I'm going to present is only a small fraction of the overall activities that ESA does in the markets of space resources, which is a multi-directorate approach, of which HRE is sort of leading the charge. But we have support and collaboration from many directorates, and many colleagues from many directorates are here to bring their own news and their own advancement. So you have the HRE, but you have tech with technology activities, you have experts, you have SciSpace, you have ELI, science, and of course also the communication and the commercialization directorate, and as the Director General, the Minister, and Daniel remembered, we have a very strong collaboration and partnership with ESRIC, which is a focal point for many activities that we do. In the particular case, we have the facilities development, the industry accelerator, the startups support program, and the community management. All of these are very important functions for a niche but growing sector, which is space resources. Because, and we heard it also from the panel, there is so many components to this problem. This is building infrastructure on a level that humanity has never faced before, And we can't do it alone. We need to collaborate with each other, internally and externally and internationally, to really bring these to reality. So, you've seen these slides before. I would like to give a bit more flavor. You see that this project plan is about de-risking. De-risking technologies, de-risking commercial aspects, and de-risking the external factor that we can't control, but we can definitely influence. For example, you have Dovile doing massive work on the part of the legal framework, because these will be fundamental to enable space resources to be part of architectures in the future. So you have the first pillar, which is a technology de-risking pillar. You have the ground-based facilities, which we started building with ESRIC back in 2020 as part of the strategic partnership with ESA. ESRIC is developing the center. ESA contributes with large ticket items, platforms that are used for research, to advance TRLs, and to open the possibility to other parties to come and use those facilities without having to rebuild them from scratch. Pillar number 2 is the support, the business support function, incubation and acceleration, which has always been there, and it started with startup support, and this year we also added the accelerator, in which we will look at how can we help sound business plans to become more than just paper. What can we do to support from a technological point of view, from an economical point of view, from a commercial point of view? Then you have pillar number 3, which is the Space Resources Challenge, which it's driven by innovation at its core. Innovation that allows procurement to happen without just relying on paperwork, but actually demonstrating on the field how it works. And that's very important because it really builds confidence. You don't have to demonstrate just the formulas. You bring your hardware, you show what you do. Then we have the community engagement, pillar number 4. And this event, and thank you, ESRIC, thank you, the Ministry of Finance, Economy, and thank you, LSA, because this is a fantastic venue. In 2018, first space resources event that we made was 150 people in Erasmus. Fantastic event. Nobody knew what we were going to do. And this is fantastic because look at the place where we are. Anyway, moving on. Pillar number 5, it's a new addition. This is not your usual procurement. This is industry-driven payload to the moon, which are co-funded by the industry. And ESA will help try and deliver small, critical technological advancements that are valuable for the space resources value chain in relation to the regulatory utilization. So as I said, this is a long-ranging plan. I love that title. We are in year 6 of a 15-year plan. We started long ago. We started delivering some hardware. We're going to deliver more this year. The reduction cells for molten salt electrolysis, next year the DTVC. And we are currently doing a feasibility study on a pilot plant, which I will discuss in the next slide. Then we have the market de-risking, which is achieved through the Space Resources Accelerator, startup support, but crucially also the space resources business case development. We have heard it from the panel before, from Lada. Everybody likes to be a scientist or an engineer. We got to make money. Or we need to demonstrate that we can sustainably increase our TRLs again and again and again. We're going to the moon, we're going to Mars. It's not going to be easy. and it's going to be risky. How do we buy down risk? We think this is the way. And then the mitigation of external factor, so participation to events like this, Space Resources Week, but also taking a leaf from Esric's clever approach to community engagement, we decided that we should have a quarterly meeting online, a webinar, anything that keeps the work going, that gives people information, first-hand information on what's going to happen next, what opportunities are there, and how they can interact with us. Now, this is my core activities. Dennis, you are famous, I told you. You are in many, many slides. We delivered the first technical demonstrator, hydrogen reduction technology that was developed by SAS. And now we are trying to upgrade that facility using plasma. It's already a system in which you have moving powders, so not static. And we thought, how can we make this better? Would plasma, with the kind of component that it brings to the table, improve this process? Can it give it a second wind? And of course, we are working on molten salt electrolysis through the JHUAPL project. As you can see, oh yeah, I got it. We have rolled the reactors, and they are being built. And of course, as I said, the DTVC, this is in collaboration with Spartan. Wow, I'm really late, okay. Spartan, to have a dedicated DTVC facility that will be made available for industry. All of this infrastructure will be made available for industry with the intent of lowering the barrier to entry for new players so that they don't have to rebuild everything from scratch. And of course, as I say, the pilot plant, which will be an open architecture where people will be invited and helped to integrate their solutions and see if they can perform better than our baseline. And if they do so, we will implement in our own pilot plant. Moving on to the pillar number 2, incubation acceleration. As I said, we work with Esric to accelerate the progress of companies in this field. How? By scouting sound projects based on sound business plans, which will access co-funding from ESA, provided that they can provide match funding. And the hope is that you will start with terrestrial demonstrator and grow and evolve until you can have lunar demonstrator delivered commercially. Furthermore, business support also includes the business modeling. Now, when I started working on this, there wasn't really a big overarching plan. And we started putting this together. And we started realizing all the components that you need to know to demonstrate to people that is actually worth doing it. Whether it's for CO2 emissions, whether it's because it makes exploration less expensive, or if it can bring benefits to humanity that weren't previously anticipated. And we will do a call for ideas in this particular space, focusing on the development of business models along the value chain. Why do we do this? Because we want to develop the operators in Europe. We want to help them create their business model, reinforce the business model, and develop the business model until such a point in which you can say, hey, it's worth investing in this for all these very sound reasons, not just I got a big idea. And then there is pillar number 3, the Space Resources Challenge. I will not spend much time because I'm late. I'm sure that you heard from Catherine. It was a fantastic new development. And now we are going to make it grow in time, because one thing we did was we had a call for ideas. These are the numbers of the Space Resources Challenge, the first Space Resources Challenge. We did a call for ideas, and we decided to create a path, a roadmap of challenges, increasing in difficulties, but also in reward, to make it a tool for advancing technologies, and do it with the push of the innovative culture that is that of space resources. And of course, we will, as Catherine said, we will have a challenge on excavation and beneficiation. Then there will be one on support to the pilot plant or to the molten salt electrolysis value chain. And then we will start utilizing the products until we can move off Earth and do the challenge in space, the real thing. The community engagement, what to say? I mean, you can see the numbers. I expect that next year, this year will be about a year. And then you can see how the growth is being steady and continuous. And you get more and more people interested from sectors that probably at the first event they didn't even know. And that's how successful the community engagement has been. And we will continue this, and as I said, we will have our quarterly, maybe, events. Oh, look, they put myself, okay. That's cheeky. In which we will discuss topics, opportunities, with the collaboration of ESRIC, internal to ESA, anything that we can do to be a mouthpiece for the community. We will house it in this particular pillar. Oops. Last but not least, the in-situ demonstrators. I asked John Verbalakis if I could steal the picture. I did. And this is above and beyond what ESA is already doing, because there is a lot of work going on ISRO demonstrator, on the technology developments of the pilot plant, but these will be industry-driven. These will be very small payloads which aim to demonstrate critical technologies that are relevant for the value chain of the oxygen and metal extraction from regolith in relation to the pilot plant, and it will be ESA co-funded. It will not be something that we go out and procure of our own volition. We need ideas from outside. And with that, I thank you all. Sorry, I took 1 minute 40 longer than I should.
Thank you so much, Mel. Thank you. Now, next up, we have two people who are going to talk together. One has come from Denver, the other from Korea. So please welcome to the stage Ian Christensen, who is the Director of Private Sector Programs at the Secure World Foundation, and also Soyoung Chung, who is a Senior Researcher at the Korea Aerospace Research Institute, KARI. Welcome to you both.
All right. Good afternoon, everyone. So we are here to talk about the outcomes of a workshop on perspective of new entrant space programs on space resources activities that we organized in the fourth quarter of last year. And as was introduced, Soyoung and I are going to share the presentation, so wish us luck in bouncing back and forth here. Soyoung, over to you to introduce the organization of the event.
Right, so the international workshop on space resources that we hosted was held at the end of last year in Daejeon, South Korea. It was jointly organized by Secure World Foundation and the 3 main public research institutes in Korea that are engaged in space resources related research activities. And those are Korea Aerospace Research Institute, Korea Institute of Geoscience and Mineral Resources, Korea Institute of Civil Engineering and Building Technology. And some of you may remember that KIGAM has established Space Resources Center and has signed MOU with ESRIC last year during the Space Resources Week.
Earlier this morning, Kathleen Hadler mentioned that we're seeing an increasing diversity in the space resources community. And one of the ways that, from our perspective, we see that diversity being reflected is in the growing interest and engagement in space resources activities by countries that have not been traditional participants in space exploration activities. And so we put this, one of the motivations for putting this workshop together was to engage the perspectives of those countries and to also engage the broader space resources community in thinking differently about approaches to effectively engage with new entrants in space resources. Secure World Foundation, for those of you who don't know us, we focus on space sustainability, and part of space sustainability is making sure that the benefit of space activities is widely accessible to all of those that participate in space. And so we've seen a need to increase communication of benefit of space resources activities, engage a broader set of participants in those conversations. And so in 2019, Secure World Foundation has organized a workshop in South Africa with a number of African space agencies on the question of space resources benefits, and wanted to kind of continue that discussion here with this event.
And what Ian has just described is exactly the reason why Korea wanted to organize this workshop as well. Korea is a new entrant in space exploration, and we have a lot of interest in space resources. So far, we only have one lunar orbiter mission. It's called KPLO, but we are already contributing to the space resources-related research. For example, KPLO is hosting a NASA payload called ShadowCam, which is able to observe the permanently shadowed regions of the moon where ice water is believed to be present. And we plan to do more in the coming future. So as we became more interested in this subject, we came to realize two things. First, we do not have a comprehensive understanding about the subject matter. We needed to study more. And second, something as big and challenging as space resources cannot be done by a single country or an entity, and we needed partners. So for this workshop, we decided to partner with Secure World Foundation and invited the international experts to Korea to understand the big picture of this subject matter and to discuss ways that smaller or new entrant countries like Korea could contribute to space resources ecosystem.
So the workshop was a 3-day event held in Daejeon, Korea. First 2 days were a public conference. So we invited members of the Korean space community, government, academia, industry to attend and hear briefings from the experts that we brought in. On the third day, it was an expert-only workshop, so we took the speakers and a number of high-level experts and did some interactive exercises. So in the next set of slides, we'll sort of talk through the elements of the program.
And along with the workshop, technical tours were also organized, and international participants had the opportunity to visit the facilities of KARI, KIGAM, and KICT over 2 days. And this served as a good opportunity for the local community to show the international expert community what kind of research activities are ongoing in Korea. And facilities that were visited include KARI's AIT facility that was used for testing Korea's lunar orbiter, and the ground station where it is operated from. And various labs in KIGAM, our geology institute, that works on developing payloads and technologies related to ISRU. And at KICT, the Civil Engineering Institute, participants had the opportunity to see the large-sized dusty thermal vacuum chamber that can simulate the surface environment of the moon, and also simulate manufacturing facility and indoor lunar surface analog facilities, and etc. And this chart shows the overview of the participants to the workshop. There were over 100 registered participants, and roughly 1/3 of them were international participants, and the rest of them were local. We had around 30 international speakers invited to give a talk, and many of them are actually here today as well. And we had many representatives from government agencies, and then a good mix of experts from academia, industry, and NGO. 15 countries were represented, and you can read in the bottom of the list which countries were present.
So throughout the workshop, we had a number of questions that were reoccurring or common thematic. So we were asking experts to describe the current landscape of participation in the space resources field, discuss the current state of understanding and knowledge. We asked many of our panels and many of our speakers to comment or to give examples of how smaller or new entrant countries can contribute or be involved in space resources activities. And we also focused on partnership models. So how can, across the ecosystem, across the landscape of space resources, how can we engage in effective collaborations and partnerships, and can we point to specific examples? These sets of questions kind of had two audiences. So first, there was the public participation that we had from the Korean aerospace community, and then the questions are actually designed to encourage thought and communication amongst the experts themselves. So we were asking policymakers, we were asking business experts, and we were asking scientists and technologists to comment on these questions and helping to build a little bit of cross-disciplinary conversation there, and also hoping to continue conversation on these questions after the workshop ended.
So for the first 2 days of the workshop, we had a dedicated session where we invited space agencies to give presentation on their space resources-related plans and activities or interests. You can see the list of countries and space agencies that made the presentations. And as you could imagine, there were a range of space resources activities that were being planned or being considered by various agencies around the world. But most of the planned missions for the moment focused on resource assessment and ISR detect demo. And the target use cases included propellant and life support, construction and manufacturing, and there was also one country with special focus on space farming, which we found very interesting.
So time is moving very quickly already in these presentations. So the panel discussions covered 4 multidisciplinary topics. We had a discussion as of scientific knowledge and interest, a discussion of ISRU technology, discussion of private sector drivers of space resources activities, and a discussion of policy and governance issues in space resources. So as I said, across these panels, experts were asked to identify partnership opportunities and discuss ways of collaboration between these different sectors. Moving then into the third day, we had a number of interactive activities. The first of these was a scenario exercise in which the expert speakers were divided into 3 groups. And in these 3 groups, they were asked to play roles of commercial, governmental, scientific, and civil society organizations stepping outside of the role in which they occupied in their daily life or in their real life, and were asked to build a cooperation model to respond to an established space agency which was seeking to build a consortium to develop resources at a site on the moon. The workshop was designed for participants to consider the different ways and different benefits of a cooperation model. So looking at considering the objectives, the benefits and challenges of building cooperation in space resources utilization. The scenario had 2 rounds. First, they were asked as a group to build a response to this call. So looking at the different roles in the group, commercial, government, civil society, how could they collaborate together to build into this international consortium? Then a change was introduced in the scenario in which a commercial actor became more of a driver, and the participants were asked to respond to that. The way this exercise worked is that participants were first asked to consider in their individual roles what objectives, capabilities, and goals does one have in their role for entering into a partnership, and then asked to work as a group to find ways to work within those objectives to build a more cooperative endeavor. Following the scenario exercise, we brought everyone back together and had a discussion of the outcomes and what we learned. And I want to emphasize 2 points here. The first one was that the importance of governance emerged very quickly. And I think it was somewhat surprising to us to see this, but both folks that were playing and representing government organizations and folks that were playing and representing commercial organizations said that in order to develop a large-scale activity like the one in the scenario, it was necessary to have basic governance principles in place to kind of set up the conditions in which parties would interact with each other and then with the environment. We also then saw a lot of discussion from the groups that partnerships can be built where all of the parties don't necessarily have the same objectives at the same level. So one group noted that different opportunities can be pursued at different timeframes within a cooperation. Another group noted that structure of a cooperation model can be developed that gives individuals the ability to pursue certain priorities while a group pursues an overall objective. So the participants noted that, everyone might want to cooperate, and that's good, but you need to have a good understanding of everybody's objectives and your own coming in to be able to navigate through a set of multiple priorities.
So during the workshop, we also did some participant survey, and anyone who was at the workshop could take the survey online. So we did get some interesting results and wanted to share some of them here. In this chart, the question was, when do you expect the extraction and use of space resources on the moon will be realized? And nearly 60% of the participants answered 5 to 10 years from now. And a little less than 27% thought it would take longer, maybe around 10 to 20 years from now. And on this chart, the question was, in your view, what is likely to be the most valuable space resources? And as expected, water or ice came out to be on the top of the list. And what's interesting with this audience is that helium-3 was was the second on the list, and meaning that it gained more votes than non-water volatile elements or precious metals and regolith. And I think this is because majority of the participants were Koreans, and there's a lot of media coverage about helium-3 and bringing it back to Earth for nuclear fusion. But I know that many subject matter experts would not agree with this answer.
So we're already at time here, so I'll be very brief. Two other questions we asked is how likely, we're trying to get at issues and concerns, we asked how likely advanced countries might monopolize space resources, and here we did see a fairly notable concern from our audience that this was an issue that they were concerned about. We also asked about the potential for conflict over space resources on the moon in particular, and again, this is an area we saw some concern from our audience. So Young, if we can be quick through these, talk about the myths and concerns here.
Right, so with this survey results in mind, we had a discussion session on the final day where we talked about the myths and concerns held by the general public. And on the left is a summary of the myths that we had identified. We recognize that some people believe that large-scale space resources activities are about to happen in the near future. And we also recognize that many people believe that space resources activities are about returning resources to Earth. And the next one would be both myth and concern, but we recognize that some people tended to believe that advanced countries and leading commercial actors will monopolize space resources. We also found that some people believe that space resources will create trillionaires in the near future. And finally, some people seemed to believe that there was immediate potential for geopolitical conflict over space resources.
So on the concern side, concern about communication of benefit and making sure that we are giving the right justification, the right exploration of what we're doing in order to build public support, as well as we've mentioned, some concerns about the potential of conflict. And I think one of the more interesting ones was the need for implementation of governance principles to be driven by scientific realities. So very briefly,
So this is the final slide, and on the left is a summary of the overall outcomes of the workshop. So throughout this workshop, the participants recognized the importance of multidisciplinary interactions and collaboration. And we also recognize that continued opportunities to build awareness and partnership among various actors was important. And also the importance of sustainability was well recognized and emphasized throughout the event. And need for improved attention to communicating the benefits of space resources was also emphasized.
So in terms of next steps, I think one of the key themes that we heard out of our participants was this need for better communication of benefits. So we heard a recommendation of a focused effort should be made to analyzing and communicating the tangible and economic and other benefits of space resources, as suggested at existing forums such as this meeting, the Space Resources Roundtable in Colorado, could be used to catalyze community effort towards that. There's also a suggestion that we establish a formal platform to enable new internet nations and established nations to kind of share their space resources activities. We also saw a strong interest in continuing this conversation, and with that, just a very quick announcement. Secure World Foundation and the Brazilian Space Agency, AEB, are planning to hold a similar workshop in the fourth quarter of this year, and we welcome participation. So, with that, I think it's sometimes harder to keep a conference on time than achieve a space exploration program, so thank you, and we'll get off the stage now.
Thank you.
Thank you. Thank you very much. Thank you. It was really interesting research there. I just also have to highlight that somebody's lost a phone. So if you have lost a phone, it's at reception. There's a waving hand here. Oh, it's not. It's just a random wave. Wonderful. Next up, we have a stalwart of this conference. Everybody knows him, anyone who's been to this conference more than once, and we all wait in anticipation of the Jerry Sanders eyesight test, which is your slides, which are always rather colorful and rather busy. Jerry, yours.
Thank you. Thank you, everybody. So I'm taking a different twist on my charts this year on the subject of building a sustained international activity in space resources. So a number of years ago, I was giving a presentation to a mining conference and decided to talk about what are the barriers that exist to commercializing and making space resources more international. And so I thought I would resurrect that chart and put a new twist on it. So the colors do have meaning here. Green actually means good. Yellow means it's getting there. Red shows that there are issues that still need to be worked. And when I did this chart a number of years ago, there was a lot more red on it. So the 5 barriers: resource uncertainty. Before you do any mining operation, you have to understand the resources, so the level of resource exploration and such. The next is, do the technologies exist? So if you were part of the professional course that Colorado School of Mines and On Hill and Luxembourg Esric hosted before this conference, you have to understand that you not just have to know where the resources are, but you have to have the technologies to extract them. The third barrier is you actually have to have customers. Doing this for no reason or without a customer doesn't make any sense. So who are the customers? What's the potential growth in market? And we heard about investments before. The fourth is sustainable operations. When you do ISRU, you need a lot of other things to basically occur. You have to have transportation systems to and from your mine site. You have to have logistics and maintenance and overall infrastructure to support your operations. And then, as is going on in the parallel session, regulatory. Before anybody can really get into space resources and mining, you have to discuss the legalistic aspects of it. Property rights is an important aspect, standards, and even taxes. So starting with the resource uncertainty, a lot is going on, a lot has gone on, and we're really making a good effort to understand the resources. We know a lot about the regolith on the moon from Apollo and other missions. However, the water and the volatiles in the permanently shadowed craters still need a lot more work to do. So, we have a pretty good start, but more is needed there. And on the bottom, when we talk about these space resources and understanding where they are and how they're distributed, this does need an international collaborative effort. And a colleague of mine, Clive Neal from the University of Notre Dame, is working on this with many of us and trying to, how do you establish this kind of international aspect? And it's, again, not just are the resources there, but from a mining perspective, are they proven, are they inferred, and such. The next is the mining technology. So Melchiorre touched on this a little bit on the European side. On the US side, we've made tremendous strides in both the water mining, cleanup, and extraction and electrolysis of the water, as well as oxygen and metal extraction aspects, and you'll hear more about that over the next few days. Another aspect is, we talked about the pilot plant, other folks has mentioned this. So it's not just the technologies, but you have to show end-to-end that all of these things can occur with some level of repetitiveness, some duration to buy down the risks. And a lot that goes into this, you've heard, is how do you test them on Earth? My colleague who's about to talk from APL will talk about proving grounds and facilities. You heard about Luna. Down here on the chart, or up there on the chart, you'll see within NASA we have fairly large dusty vacuum chambers. We're also looking at a very large analog facility near the Johnson Space Center in collaboration with the Texas A&M. The other aspect of mining technologies is the fact that it's not just government agencies handing out money through different solicitations. We've started to work a lot of private-public partnerships. Vlada, who was on stage with Blue Origin, mentioned the fact that it's Blue Origin's putting a significant amount of money into their Blue Alchemist program, with NASA providing funding as well. But that's not the exception anymore. It's becoming more and more. And if you don't see your logo on these charts, please forgive me. I just put a number down, so if you want to give me a card afterwards. The other thing that's really interesting is we're seeing a lot of money coming from external, from government agencies. And I've listed a few of those. You heard about Interloon within the last couple of weeks that they're working on helium-3 mining, for example. They don't have a contract with NASA. So these companies are getting money elsewhere to work on technologies that could benefit space mining, but also may have some kind of a terrestrial aspect to it. So how do we make sure that we provide the de-risking, as Melchiorre mentioned? A big aspect is customers. And Catherine, the only graph I have is the one at the bottom there, so you can put that in for one of the things. So customer-wise, if we just look at the Artemis program, sending 2-4 astronauts for a week or two, that's really not a customer base per se. You really need to start working on the transportation systems or other aspects. So we start looking at things like, how do we build a cislunar economy? Our DARPA started the Luna 10 activity. It's a study to look at how can you create a cislunar economy in 10 years. Within NASA, we are trying to break the chicken and the egg cycle. The bottom chart shows that we're pursuing water mining as well as oxygen and metal from regolith simultaneously. And we're trying to do that with industry to show that we can make a viable product that can be used such that a commercial entity may be able to be part of that. We put out a request for information at the end of last year for our first ISRU demo, with the idea that we invest and incentivize that early aspect of the mining process, the resource estimation and the technology development. And so through these processes getting up to the pilot plant, we're hoping to de-risk and show that external investment is much more viable. And the other aspects of building customers, we like to use a term cooperative. Oh. Is it exactly driving people nuts?
Somebody online has written that should be better.
Okay. I'm sorry for the crackling. There we go. Okay. Sorry about that. Yeah, I normally just talk through microphones. That's probably better for me anyway. So how do we start working on these things? A collaborative competition. Competition is required. You want new ideas, new investments, new ways of doing business. But at the same time, we all have to kind of bootstrap each other to begin with. And so how do we collaborate in the basics, the resource assessment, the standards, the interfaces, the proving grounds, so that we can all develop things and have a chance to compete later on. So on the one side, there's a lot of consortiums that are being built up. We have the Lunar Surface Innovation Consortium that Karl will talk about, Catherine's ESRIC. There's different groups like Cosmic that gets into specific areas of in-space satellite servicing and such. The Lunar Exploration Analysis Group has had a commercial advisory board for many years. So these are forums that people can get together and start to think about, how do I collaborate with each other? How do I build up this kind of community? The other is obviously government agencies. So we work with many of these other government agencies to try to figure out, how can we collaborate? How can we provide a framework in which we can all work together, but at the same time allow companies in our respective countries to elevate upwards? When it comes to sustainable operations, the top, I guess to your left, to do space resources, it's like mining on the Earth. You have to basically have all your infrastructure around there. You need power, you need communications, you need navigation, you need support services, repair and maintenance. If you have people working there at the mines, you need to have habitats and such. So you have to basically build a whole ecosystem. And we've, from the NASA perspective, as well as ESA and other government agencies, we've put a lot of money into these other aspects. So the transportation systems, the power systems, the mobility systems, autonomy and robotics. All these things have spin-offs to Earth as well. When it comes to standards and interfaces, that's another very important thing. So again, different communities, different consortiums are trying to work these things out so that we align ourselves in the areas that make the most sense. And then there's partnerships with terrestrial markets and terrestrial mining. It was brought up this morning. Space mining is not going to make money in any time in the near future. So how do we keep these companies viable? Well, to do that, you have to have a terrestrial market. So this is where that push-pull aspect comes in, is why does doing things in space resources benefit Earth? Examples are that if you do molten regolith electrolysis with non-eroding cathodes and anodes, well, on Earth, those are graphite. Those are big CO2 polluters. So you're actually benefiting terrestrial mining activities at the same time as space mining. So those things are all very important. And then I'm not going to even talk about this one so much, but when it comes to what I have to work towards, we look across the gambit of regulatory regimes, Artemis, the UN activities going on now, national laws, and an important aspect that will come up is how do you understand the resources to the extent that they're marketable? I have takeaways. So in general, I think we're doing all pretty well. There's obviously more work that needs to be done on the ground truthing, especially of water and permanently shadowed craters. We're making significant strides when it comes to the technologies. We do need, obviously, to work on those customers in the markets. And you heard Isa talking about how they're trying to set things up. We're doing the same thing on the US side, but developing that pull, that aspect, and having terrestrial markets will help there. There's progress being made in the infrastructure and the partnerships. APL and ESRIC across the Atlantic are working together on these proving grounds and such. And again, the fact that we have a meeting tomorrow on the legal and regulatory aspects is very important. And I'll leave with a slightly humorous aspect here. My career has been working on the middle step there between lab demonstrations and these big futures. So the miracle is starting to occur. Now the business case part of it, if you know South Park, we still got to work on that question mark. And with that, I'll bring my presentation to an end.
Who's Bill? I saw there was Jerry and Bill.
Bill Larson is a colleague of mine that goes back some time.
Okay, there we go. Well, say hi to Bill from us all here. Thank you, Jerry. Thank you so much. Now, next up we have Karl Hibbitts, again a regular at this event, from the Johns Hopkins University Applied Physics Laboratory.
Hi, thank you very much. Is it working? Great, fantastic. I want to thank Ezric for the invitation. I want to thank Jerry for a great introduction, because everything you talked about, if you're interested in getting into it and you don't know really how, reach out to LSAI and we can help enable you. That is part of our job. So today I'm going to talk about what we've done over the last year, and embedded in there will be what we intend to do over the next year. I realize we're also well behind time, so while I won't rush through it, I will probably modify my talk in real time to get through this. So why the moon, why SU, why LSII in fact? Well, on the left, you can see the Venn diagram by the ESDMD, Moon to Mars Architectural Definition Document, which show the three pillars for why the moon, which is national posture, science, and inspiration. What I really want to highlight is the fact that international relationships is key. So us coming here, LSI coming here, reaching out to you, the international community, is intrinsic to our role as LSI and is encouraged by NASA. And in part, why to do this? Why LSI and NASA doing this? Setting normative standards, you see that right there. By going to the moon first, getting to the moon and extracting the resources, we're able to set how things are done. Similar to what was spoken to earlier today, we want to explore the moon, extract resources in a responsible, sustainable fashion. Finally, Jerry mentioned this as well. Clive Neal has written a few papers on them explaining why ISU, not only does this enable sustained presence on the moon, it enables a transition from a government-led to industry-led presence on the surface of the moon, and from there, exploration of the rest of the solar system. So the LSI, what is it and what is our purpose? Well, basically, we really are here to enable you. We're here to reach out to industry, academia, nonprofit, governments to develop partnerships to enable the development of technology for a sustained presence on the surface of the moon, doing this through integrating technology, maturation studies, leveraging innovative collaborations and partnerships, all with you very intelligent, capable companies out there, and utilizing uncrewed lunar surface flight opportunities that are coming up soon. And we do this through two ways. One is a technical directing agent or a trusted agent, where we tell NASA the unvarnished truth in a polite way. Very honest assessments meant to identify the technology that is needed to be developed and how to develop that technology so we can develop a sustained presence. Input from the community is intrinsic to this. The capabilities are going to be industrial capabilities that we're talking about. And the way we reach out to the community is through LSIC. And thus, this is why I'm standing here in front of you looking for input and also providing input back to you from NASA. There are 4 different focus groups or focus areas. ISRU is only one of them. In reality, it's an integrated system that's going to get us back to the moon in a sustained presence. These include not just ISRU, but also excavation, construction, surface power, and very importantly, the cross-cutting technologies that bring all these together. Things such as autonomy, robotics, dust mitigation, accessing the extreme environments and operating in extreme environments themselves. All this requires a system perspective, which Johns Hopkins University APL takes some pride in. And we build spacecraft, we do space missions, we look at things from an integrated perspective. So we are, the ISRU focus group at least, is led by myself and Jody Burtis, with Michael Nord assisting there. And Michael Nord, by the way, is leading a very important aspect of this for the next year, which is a system integration and gap analysis of ISRU pilot plant technologies related to O2 and metal extraction from the surface of the moon. So what gaps, what needs, and what kind of interfaces are needed for developing a full system, a pilot plant, for extracting metal and oxygen from the surface. This is where we're focusing, as well as understanding the needs for water ice extraction as well, not forgetting about that. So if you want to join, use a 2D code up there, take pictures of it, or simply send me an email and sign up and participate. We've changed our meeting time to 11 a.m. From 3 p.m. to enable participation by the international community. And speaking of which, just last week, we had a great presentation by Michelle Keegan from AROS related to the question of extracting, utilizing regolith for ISRU, one of our first cross-focus group meetings. We're going to have more of that for a system perspective, which related to that is an example here of how we apply it to extracting water ice from the surface of the moon. NASA, we have assessed, has all the individual component technologies being developed, not mature yet, but being developed. The biggest problem, biggest challenge that's being faced right now for water ice extraction is finding where the water ice is, okay? The knowledge is missing. In this case, I would recommend reading the recent paper by, again, Clive Neal that just came out, Acta Astronautica, which does a great job explaining the difference between reserves and resources and how the resource utilization cycle needs to happen. The point is that we need to find this water as a reserve and move away from or forward from simply treating it as a potential resource. And these need to be resources that are accessible from our upcoming landing sites. In the case, because we work for NASA, it will be, or paid by NASA, it will be some of the upcoming Artemis landing sites. And how do we find the water ice that could be accessible to these landing sites? We propose a feasibility study, or actually conducting a feasibility study to look at the technologies that are needed to enable not just the prospecting, but also the operation of the PSRs. Now, related to prospecting itself, the first step could be, and this is just one example of the approach to looking for the resources, is a low-altitude small-sat mission to screen the location to a few kilometers so that then we can go and say, okay, there's a resource there, actually very likely a reserve, an accessible reserve. Now let's go and pinpoint it and characterize it in more detail, which would be the next studies. And NASA's already looked in this to some extent, how to do that. I do want to point out that DARPA just released an RFI called Shale with 6 themes in it. One of the themes being actually a low-altitude small-sat mission to constrain the location to a few kilometers. So it's not just NASA that's thinking about this. It's, you know, the larger industry as well. So in just a couple of minutes, I just want to go through a few highlights and not go into any details of the some of the results that we have from this last year. We had a Lunar Proving Ground workshop, and it was wonderful to see the work that's already being done by ESA with the Luna facility. That itself is going to be a fantastic proving grounds for technologies. And most importantly, what we identified is the need to prove out technologies not just at the component level that can be done in the TVAC chamber, but at the system level. How do you operate it, manage it, repair it, maintenance, the whole thing that normally isn't actually validated in the TVAC system. You need a proving grounds to do that. So look at ESA's doing it. We understand there may be some development in Texas as well. Also, we do some studies as well, including this one, which is going to be presented, I believe, later today by Paul Burke, to explicitly enable and address gaps that others aren't addressing in the viability of specific technologies. This particular one is for the extraction of bubbles from molten regolith, which is applicable to a couple of types of oxygen metal extraction from regolith technologies. What we're looking at here is the scalability of bubbles to actually come up through the magma and detach from the cathode if you're using MRE so that can be extracted. Is it scalable from a laboratory demonstration to a production plant, and what would we want to demonstrate on the surface of the moon if that were the case? So I've saved us about 4 minutes, and pardon me for rushing through it, but I want to end with the same theme that others have talked about today and this morning, is that all this is great and fantastic, and it is very important that we do this in a sustainable, responsible, and inclusive manner so that we have support, not just support, but actually the active support and collaboration internationally through the community, including the traditionally non-spacefaring nations. That way we can all go there together. And with that, I will end it. Thank you.
Thank you so much.
Tried to save you 3 minutes.
You spoke very fast indeed.
Oh, I'm so sorry about speaking too fast.
No. It was a great lesson in listening to English in another speech.
Oh, God.